Okay, so let's talk about how to work steam expansively. This was one of the reasons that British engine builders were able to make engines small enough to fit on railroad tracks. This is one of the reasons why British steam engine designers were able to get so much greater efficiencies out of their engines. They're working steam expansively. So let's set up our foam core steam engine and place the piston in its starting position. Now, with the valves open to the boiler, the pressure here in the cylinder is going to be equal to that of the boiler. And then the piston starts to move. But rather than just let the piston keep moving, let's close the steam valve. And let's isolate, you notice the steam can't escape, and let's isolate the piston. Now the steam is going to continue to expand. It's going to cool, but it's going to continue to expand, and it's going to continue to push on the piston. Now we'll open up the steam valve, and we'll start steam in on this side, and again, the piston's going to start to move. It's going to start to move. But now we're going to isolate the cylinder. So the steam is going to continue to expand. It's going to continue to do work. It's going to do work and expand and lose some of its heat or lose some of its temperature, where its temperature is going to decrease. So let's go and look at an indicator diagram. All right, now, got to fix that valve. Okay, we're open here. The pressure is equal to that of the boiler, and the piston starts to move. So this is the first part of the indicator diagram. The piston is moving. The pressure is equal to that of the boiler. And then we shut off the valve. Isolate the cylinder. The steam is going to expand. The pressure is going to go down. So that's this part of the indicator diagram. The pressure is going down and the volume is going up. Pressure is going down, volume is going up. We're working the steam expansively. Now, we open up the valve to the atmosphere. We open it. So now the pressure is equal to that of the atmosphere, which would be right here. And the piston starts to move back. The volume is decreasing. So the pressure is equal to that of the atmosphere. It's low pressure. The volume is now decreasing. Pressure is the same. And we then open the valve to the boiler. So now the pressure rises again back to the pressure of the steam coming in from the boiler. Working steam expansively vastly increased the efficiency of the steam engine and made it possible to get a lot more power out of the same amount of fuel. So now we've finally come to the point of Sadi Carnot is thinking about the motive power of steam. Let's recapitulate all the things that Sadi Carnot was thinking about or knew about. He knew that you could work steam expansively. He knew that you could have a high energy reservoir and a low energy reservoir. And he thought if you could think of the high energy reservoir in terms of its heat and the low energy reservoir in terms of its heat, You could think of it almost like a water wheel. You could think of it almost like a water power system, with a high energy reservoir or a high heat reservoir or a hot reservoir, and a low energy reservoir, which he called a cold reservoir. We call a cold reservoir. And caloric fluid, Carnot, alas, was a believer in the caloric theory, or energy, as we would say today, was flowing from the high energy reservoir to the low energy reservoir, and it was doing work along the way. Now, with that in mind, what did Sadi Carnot postulate as the theoretically maximally efficient heat engine?